Hello friend, myself Sanjeev Dwivedi and on behalf of Vidyalankar Institute of Technology, I welcome you all in this concept video session for subject advanced algorithm. In this video, we are going to talk about a, an example of advanced data structure, that is a binomial tree, and how we will combine binomial tree to make binomial heap. Let us talk about few properties of binomial tree. Now here, let me first demonstrate a binomial tree to you. See, this is binomial tree of order 0. Now, when I say binomial tree of order 0, it means it will have 2 raised to 0 nodes. 2 raised to 0 is 1. This is binomial tree of order BK. So now what we say is binomial tree. Let's say this is binomial tree of order 0. Binomial tree of order 1 means it will have 2 raised to 1, 2 nodes. It will have 2 raised to 2, 2 2s are 4 nodes. It will have 2 raised to 3, see 2, 2, 2, 2, 8 nodes. This is 2 raised to 4. We will have 16 nodes. So one interesting thing that you should remember is, first thing, a binomial tree BK will have 2 raised to k nodes, and the height of the tree is k. Now why I'm saying k, just have a look. This is binomial tree of order 4. So height, so the first level is 0 level. The height is 1, 2, 3 and 4. So B4 is a binomial tree of height equals to 4. B4 is a binomial tree of height equals to 4. So the second point, there are exactly KCI node at depth I. See, please try to understand. There are exactly KCI, that's combination, nodes at depth I. Okay. Now let's talk about depth level 3. Let's talk about depth level 3. What is k value here? 4. So it is 4c3. Now what is 4c3? It's 4 into 3 factorial upon 3 factorial. 4 minus 3 is 1 factorial. That's gone. So what we have, we will have value as 4 only. To check at level 3, how many node we have? 1, 2, 3, 4. Exactly 4 node. So this is one more property. Now what it says, a root has degree k, which is greater than that of any other node. Moreover, ध्यान से, if the children of the root are numbered from left to right, k minus 1, k0, child I is root of subtree b of I. Now, see what it says. The root has degree k. Now, when I say k, see, this is root here. What is degree 0? So root is degree 0, means there are 0 nodes associated with this. When you say degree, it means how many child of that node. Now here let's say k is 2. So it will say, it says, see, the root has degree k, means root will have k child. So here degree is 2. So root will have 2 child. This is my root. It will have 2 child. Here degree is 3. So this is my root. It will have 1, 2 and 3. 3 child. Here B4 degree is 4. This is my root. Root will have how many child? 1, 2, 3, 4. Please try to understand. Okay. And what it says? It says, if the children of the root are numbered from left to right by k minus 1, child I is a root of subtree b of I. Now why I'm saying this because this is very important feature. What it says, just have a look at this feature. Binomial tree bk, okay, binomial tree of order k will consist of two binomial tree of order k minus 1. Now try to understand. Let's say b2. If you have a look at b2, what it says, this is how it is. Now b2 is a connection. It is basically linkage of two binomial tree of order 1. And let's say b1 is connection of 2. See, this is b0. And when I say b1, this is what we have. So basically it is combination of two binomial tree of order 0. So b2 will be combination of two binomial tree of order 1. b4 will be, see, this is b3. It is combination of two binomial tree of order 2. Check. This is b2 and this is b2. We combine them to make b3. Now let's say b4. See, this is b3 and here we have b3. So what we have is we have combined for b4 we have combined two binomial tree of order 3. So this is what we have, and why we call it as binomial tree, because the terms are KCI, they are binomial coefficients. Now it is a binomial tree is an ordered tree defined recursively. The binomial B0 will contain single node, like the way we discussed. A binomial tree of order k will have 2 raised to k nodes. And this is one very interesting aspect. See, if I am having a binomial tree of order k, it will be combination of two binomial tree of order k minus 1. So this is about binomial tree. Let me discuss a binomial heap with you. Now, what is binomial heap? See, if you see, this is a binomial tree of order 0. Okay, now, what is this? A binomial tree of order 2. What is this? B3. Correct? Na? Because why B3? Because see, it is combination of true binomial tree of order 2. This is actually B2 and this is B2. So this will be B3. So what is binomial heap? It says that observe a binary representation of n. Now a binary representation of n will have lower bound log n plus 1. Now why I'm saying lower bound log n plus 1? Let's say 13. If you see log of 13, now if you see log of 13 to the base 2, now try to understand what I'm trying to say. If you see log of 13 to the base 2, you will get something 3.700, but I'm talking about lower bound, correct? So here it will be 3. So it is 3 plus 1, 4 bits. So what it says basically, if I'm having any a binary number, any number n, and I'm going for binary representation of the number, so it will have a lower bound of log n plus 1 number of bits. Now, how do we represent it actually? How do we represent it? See, each of this lower bound of log n will represent a binomial tree. Correct? See, therefore, binomial tree B of I appears in H if only B of I is 1. Now, what do you mean by that? Let me demonstrate you. See, binary representation of 13 is 1, 1. See, it is 1, 1, 0, 1. It is 1, 2, 4, 8. 8, 4, 12 plus 1, 13. Now, this is actually what? This is 3. Now, when I'm saying, see, B log n minus 1. Why I'm saying B log n, lower bound of log n. So, 13, lower bound will be 3. So, this is actually B3. This is B3. This is B2, this is B1, and this is B0. Now, if you say B3 has 1, B2 has 1, B1 has 0, it means that binary tree of order 1 will not be present here in this representation. Yes, for binary tree for order 0 will be present because we have 1 corresponding to it. And this is what it means to say binomial tree B of I appears in the heap H if and only if B of I is 1. See, B of I is 3, B of 3 is 1, so we have B of 3. Check. B of 2, B of I is 2, B of 2 is 1, yes, so we will have B of 2. B of I is 1, B of 1 is 0, yes, so we will not have a binomial tree of order 1 in the heap. Now B0 means of order 0, is it 1? Yes, so we will have it. So what is this? We have binomial heap. This is binomial heap. And if you can see, it is in ascending order. So we have B0 and then we have B2. It is in ascending order of the tree. Correct? Now in this lecture, we talked about binomial tree. We talked about binomial heap. There will be certain properties of binomial heap. How we are linking it. See, there is some linkage like H is the head of heap. The head of it is heap is right now 10, and then we have a pointer that points to the next node, which is right node. We can also there is a term coined for it, and we will know why this kind of arrangement is done and to facilitate what. So in next video we will talk about it. Thank you.